Hello, I am Professor N.B. Hulle from G.H. Raisoni Institute of Engineering and Technology, and in this video we will try to understand the concept of supermesh analysis. But before that, I will take one simple problem and then we will move towards the concept of the supermesh analysis. Now here in this case we want to calculate all loop currents by using the mesh analysis or loop current method. Now here in this case we have three loops. I will mark the straightforward currents. Here for the first loop current is I1, for the second loop its current will be the I2, and for third loop its current will be I3. Now for third loop I am assuming the direction of the current as anti-clockwise because there is a given current source. That loop current we are assuming it as same as the direction of the given current source. We can assume opposite but concepts are different. Right now I am not discussing on that. Now here what we will do in case of the mesh analysis, we will apply the KVL to each loop. For that particular case we will mark the terminals. Now here for the loop 1 terminals will be this is plus and minus. For loop 2 current I2 is flowing in the clockwise. For resistor 5 ohm it is upward, that's why plus minus. For 10 ohm resistance plus minus, that is forward. For 5 ohm it is plus and minus. And for the for third loop which current is I3, and here I3 is flowing downward, its polarities will be this is plus and this polarity will be the minus. Now why we are applying the KVL to the loop? To calculate the current I1, but here in this case this problem is very simple. No need to apply the KVL for loop 1. From loop 1 directly we can get the value of the current I1 which is equal to 10 amperes, and this is the equation number 1. Similarly from the loop number 3 we will get the value of the current I3 which is equal to 5 amperes. Now what is the case? Here in this case if we have taken this direction of the I3 as a clockwise, in that particular case we have to take this value as a minus 5 amperes. That's it, otherwise not required. Now here we have the two equations. Now we want to have a third equation. For that case we will apply the KVL to the loop number 2. If we are applying the KVL to the loop number 2, in that case we will travel from this particular point in the upward direction. If we are traveling in the upward direction, that is positive to negative which is minus, its resistance is a 5 and its current is I2 minus I1 because we are following the sign conventions of the I2. Then for 10 ohm resistance, positive to negative because we are traveling in the clockwise direction, positive to negative which is minus, its resistance is 10 and its current is I2. Finally for 5 ohm resistance, that is positive to negative which is minus, 5 is a resistance and its current will be, that is I2 minus it is I3 because we are following the sign conventions of the I2. If we are simplifying this equation, this will be minus 5 I2 minus of minus it is a plus 5 into I1 minus it is 10 into I2. This is minus 5 into I2 minus of minus it is plus. This is 5 into I3 which is equal to 0. If we are simplifying further, its equation will be 5 into I1, then minus it is 20 into I2, then it is a plus 5 into I3 which is equal to 0, and this is the third equation. Here this is the equation number 2. We have three equations and three unknowns, and solving these three equations simultaneously we are in a position to find out the value of the current I1, value of the current I2 as well as value of the current I3. Here I am not going in detail in the calculations because the calculation can be done by the engineering student. It is expected that's why I will leave the calculation on you, and I will move towards the concept of that is supermesh analysis. Now here in this case supermesh analysis, exactly it is not named as supermesh analysis but it is a modification of the mesh analysis due to some difficulties. Now what is the problem in this particular case? The problem statement is given that for the network shown below, calculate current in 8 ohm resistance using the mesh analysis. And here this resistance is 8 ohm resistance. In this case we want to calculate the current in the 8 ohm resistance by using the mesh analysis. Indirectly we want to calculate the value of the current I3 in this particular case by using the mesh analysis. But what is the difficulty for this particular case? Here basically we don't know the two things. We don't know the current flowing through the voltage source and voltage across the current source. Voltage across current source is unknown directly, we have to calculate it indirectly. Similarly, current in the voltage source is not known directly, we have to calculate it indirectly. In the similar way, here for this particular case, I have taken the three loops. First current is I1, second current is I2, third current is I3, and depending on the assumed directions of the current, I have marked its polarity plus minus for first loop, second loop, as well as for the third loop. Now here in this case, never hesitate to take the direction of the current. It may be clockwise or it may be anti-clockwise. I have habit to assume the current as always clockwise. That's why here clockwise, clockwise, and clockwise I have taken the three currents. Now here, what is the difficulty, or where is the difficulty? If we are trying to apply the KVL to this loop, first loop, we know the voltage across this branch, voltage across this resistance which is 2 into I1, voltage across this resistance which is 2 into I1, but we don't know the voltage across this 5 ampere current source. That's why we cannot apply the KVL to the first loop, KVL to the second loop. We can apply the KVL to the second loop only. Here is a difficulty. Now first what we will do, what is the KVL statement? KVL statement is nothing but algebraic summation of the EMFs and potential drops in any closed circuit is 0. Here, in this case, in place of assuming this is as a loop or this is as a loop, I will assume this is as a mesh, and that's why it is the combination of the two loops or two meshes. That's why it is known as a super mesh. That's why this particular analysis or this particular method is known as a super mesh. Means whenever we have the current source in between. In the previous example, what we have the similarity. Here the current source is there, but it is in the outermost loop. And whenever the current source is in the inner branch or in the common branch, in that particular case, we have to use this concept of the super mesh analysis. Now here, first I will name this figure as it is A, this is B, this will be the C, this is D, this is E, F, G, and H. Now here, I will apply the KVL to super mesh, that is A, B, C, D, G, H, and A. This is super mesh. I am taking this is as super mesh, and we will prepare first equation. Now if we are traveling from this point here in the clockwise direction, we are traveling from the negative to positive, which is a plus. Its voltage is a 50 volt. Then positive to negative, which is minus 2 into I1. Then we are in place of coming down, because we don't know this voltage, that's why we are moving further. That is positive to negative, which is minus. Its resistance is a 3 and its current is I2. We are coming down, positive to negative, which is minus 3 into its current is I2 minus I3, because that branch is common for the second and third loop, and we are following the sign conventions of the second loop. Then we are coming back, positive to negative, which is minus. Its resistance is 5, its current is I2. We are coming back, positive to negative, which is minus. Its resistance is 2 and its current is I1, which is equal to 0. In this way, we are applying the KVL. Now, if we are separating the terms here, this will be 50 minus it is 2I1 minus it is 3I2 minus it is 3I2, then minus of minus plus it is 3 into I3, it is minus it is 5I2, then minus 2I1, which is equal to 0. If we are simplifying, here the things will be something like this. This is 2I1 and this is 2I1, it will be minus 4I1. Then we have here minus 3I2, minus 3I2 and minus 5I2. That is 3 plus 3, that is 6 plus 5, 11. That is minus 11I2. Minus 11I2. Then here we have this plus 3I3. Then plus it is 3 into I3, which is equal to 0, and I will call it as equation number 1, which we have got from the super mesh. That is mesh number, that is ABCDGHA mesh. Then we will apply the KVL to, loop number 3. If we are applying the KVL to the loop number 3, we will travel from this point into the loop in the upward direction again. That is positive to negative, which is minus. It is 3 into its current will be I3 minus I2, because we are following the sign conventions of the I3. Then positive to negative, which is minus 6 into I3. Then minus it is 5 volt. Because we are traveling in this direction, positive negative, that is minus 6 into that I3, then positive negative, which is minus 5, then positive to negative, which is minus 3 into I3. We are coming back, positive to negative, which is minus 8 into I3, which is equal to 0. This is the application of the KVL to the loop number 3. Here in this case, we are applying the KVL to this super mesh, as well as KVL to the loop number 3. If we are simplifying it further, it will be minus 3 into I3, minus up minus it is a plus 3 into I2, then minus it is 6 into I3, minus it is a 5. Minus it is 5, then it is minus 3 into I3, then minus it is 8 into I3, which is equal to 0. If we are simplifying further, it will be 3 into I2, this is 3 into I2, then it is minus 8 plus 3, 11 plus 6, that is 17, 18, 19 and 20, means it will be 20, that is minus 20 into I3, which is equal to 0. Which is equal to plus 5, which is equal to plus 5. This is the equation number 2. Now we have the two equations. Now what about the third equation? Now here third equation can be obtained from KCL, that is applying the Kirchhoff's current law at this particular node, or maybe at this particular node, or maybe from the branch that has different concept. Now here, if I am assuming this is as a node C, then while using the KCL, we have to think about the branch currents. What is a branch? Branch is a path between 8 nodes. This is one branch, this is second branch, and this is the third branch. Now here, its current already we have mentioned, this current is I1. Because I1 is flowing, is 2 ohm, it will be forward. I2 in 3 ohm resistance, it will be forward. And here, current in this branch, it is a combination of the two currents. I am not thinking about these two currents, which is I1 minus I2, maybe I2 minus I1. This current is a 5. Means current in this branch is a 5 amperes. We will apply the KCL here. What is the KCL? KCL is that incoming currents towards any junction is equal to the outgoing currents from the junction. If we are applying KCL at node A, if we are applying the KCL at node A, what is the KCL? Incoming currents is equal to outgoing currents. Now here in this case, I1 is incoming as well as 5 amperes is also incoming, which is equal to outgoing current, which is I2. That is nothing but this. Now we are not thinking about the loop currents. Now we are thinking about the branch currents. Now here in this case, and from this we will get equation something like this. We will get equation something like this. That is I1 minus I2, which is equal to 5. Which is equal to 5. This is the equation number 3. Now here we have 3 equations and 3 unknowns, and solving these equations simultaneously we can find out the values of the current, or value of the current here I3 in this particular case, which is the current in 8 ohm resistance. Again here I am not going for the calculations of all these, because calculations are simple in this case. If we have the latest calculator, this is the equation number 2, whatever we have, and this is the equation number 3, whatever we have. This here, solving these equations simultaneously, we are able to calculate the values of the current, or value of the current in the 8 ohm resistance, and this particular concept is known as super mesh analysis. Means sometimes if we are not able to apply the KVL, due to the presence of the current source, because we don't know the voltage across current source. In that particular case, we can use this particular concept, which is known as super mesh. Thank you for patience listening. This is stuff from my side for the super mesh analysis. In the next video, I will discuss the concept about the node analysis first, then some problems on the node analysis, and then I will consider another concept which is nothing but the super node analysis in that particular case. Thank you.